Okay, so this question was that there is a prism, some prism is there, okay, angle A is there, and they are saying that the minimum deviation is equal to A. Then what is the possibilities of mu? What is the range or what is the values of mu? Right, that's what it is. So minimum deviation formula, if I take minimum deviation formula is 2I minus A, right? And suppose this becomes equal to A, then this becomes 2I minus A. Then that means 2I becomes equal to 2A. That means I become equal to A, right? If I become equal to A, then what? Then if I use here incidence I am taking and all that, so mu 1 into sine of I is equal to mu into sine of R. Sine of R with R1 we are taking, but minimum means it is becoming A by 2, right? You know that R1 is this. So from here, I is equal to A only. So sine of A is equal to mu times sine of A by 2. Now here sine of A I will write as 2 sine. You see the application of trigonometry, how nicely all these applications comes. Mu times sine of A by 2. So sin A by 2, sin A by 2 get cancelled. So from here, cos A by 2 comes as mu by 2, right? Cos A by 2 comes as mu by 2. This is R now, you know now minimum deviation R1, R2 is equal to half of that, right? That's it. That's what it is. So here the normal comes, this is I, this is R1, and this is R2, this is 2. So R1 equal to R2 is equal to A by 2 at minimum deviation. At minimum deviation. Right? That is what condition we are applying. Okay, so we got one idea from here, but next is how do we take that other idea? Other idea we can take from here that A is less than 2 times of, I think this is what we can take, is less than 2 times of this. So if I use this idea, A is less than of this means, um, let me apply that. So that means sine of A is going to be less than sine of 2 times of critical angle. Okay, 2 times of critical angle. And mm, if I consider this sine of A, anyway, so sine of A, no, so sine of A is less than sine of 2 times of critical angle. Then sine of A, I think A is I. Huh? A is less than critical. So sine of A is less than 2, and now A is equal to I or I equal to anyway. So this sine we will write this as 2 sine of critical angle into cos of critical angle. Okay, sine of. Then this sine A also we can break if we want, right? Because we got it in terms of. And anyway, this 2 times sine of critical angle is 1 by mu. Cos of critical angle is root under 1 minus sine square. So root under 1 by this. Okay. And sine A will be becoming how much? Because sine A can be written as 2 sine A into cos A. So sorry, A by 2 into A by 2. So this becomes mu by 2, and cos again becomes root under 1 minus this. So mu square by 4 it will become. So this will anyway get cancelled. it will become mu times root under 1 minus mu square by 4. So from here, there is an inequality equations comes. Okay. So if I multiply this mu square become root under 1 minus mu square by 4 will become less than 2 will become root under 1 minus 1 by mu square. Suppose now if I square it, so it will become mu power 4, okay, and then root will go with 1 minus mu square by 4 less than this will become 4 1 minus 1 by mu square. Okay. So let us try to take this out. So if I open this, this is going mu, mu power 6 by 4 will become less than 4 minus 4 by mu square. That becomes quite heavy. So then it comes like from here 4 times 4 mu power 4 minus mu power 6 is less than this 4 will 4 get 16 minus 16, right? So this 4 mu square will come. So 16 mu square minus 16. This mu square will multiply here extra. So 4 mu power 6 minus mu power 8 is becoming as 16 mu square minus 16. This becomes quite a heavy thing, mu power 8, and this become minus 4 mu power 6 plus 16 mu square minus 16. This must be greater than 0. This type of some equations are we getting. And okay, anything is possible. Let's try this. So if I take mu power 6 here, so that is mu square minus 4 plus if I take here factor is not going to come because these are 16 16. Mu square minus 1 will come. Will not get. Correct. But check what mu square do we get value. Suppose I put mu square as 2. Does it satisfy this equation 0? Suppose I put mu square as 2. So this become mu power 4 now. So this become 2 power 4 minus mu. So 4 into cube means 8 it will become plus 16 into 2 minus 16. Is it becoming 0? Check that. 2, 2, 16. Okay, 16 will become 0. Yes, it is becoming 0. That means from this equations mu square is equal to 2 is definitely a root. Okay. So root 2 factor is coming, and if you put it 0, that is not satisfying. This negative, it has to be positive. I think here only some factor mu square comes out, and um, mu square should give values 2. So of course minus we cannot take, so mu should be root 2, right? Root 2, but how it is lesser than 2? Lesser than 2 we cannot calculate. Might be something else will be there. Okay, not just this. This we are getting from here. Did they also give the value of angle of prism? Yes. Hmm. No, no. Tell me what mu is equal to sine of minimum deviation by 2 by sine of a by 2. Yeah. Then it will become sine of a by sine of a by 2. This will become cos A by 2. After that, no, no, after this, which angle? Why not? Why not? Why not? Why not the prism can be like this? This is making 120 degree. Why not? No, 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 no. Here also reflection will happen. No? Prism can have larger angles also. Why only? No, no, no. Something else will be there. Maybe question is not complete. They must give conditions, then only we can calculate. We cannot say that angle. There are prisms which have more angles also. Angle I must be less than 90. They have done it, but it is not necessary that A has to be less. We can have same. We can have like this also. No? More than no. No, no. Suppose, for example, I take this type of question and I put I cannot be more than, that is what it is. Yes. I cannot be more than 90 degree. Mhm. Yes. A will be less than 10, then that condition can come. Right, right. That condition can come. So condition of A will be between 0 and 90 degree. So if I take this, then A by 2 will be in between 0 and 45 degree. Then if I take cos, because I have got mu as 2 times of cos A. So if I take cos of this, cos of A by 2, cos of A by 2, if I apply cos, cos 0 is higher now. The cos of this will be between cos 0 and cos of 45 degree. Reverse, the sign will reverse. That means this is what cos of A by 2 will be between 1 by root 2. Okay. Then I multiply with this as 2. So 2 will be 2 cos A by 2 greater than 2 times of 1 by root 2. This is what is new, right? Okay. That's what it is coming. Yes, this approach is right. Because from here we will not be able to solve that. Limiting angle you can take, but it will go something. It may come some other routes also. Okay, this approach is better. That means we have to, but angle in general angle can be anything determined. But here I has become equal to A, that is why it is. Okay, that's what it is done. Yes. Okay, next. Next, any doubts you have? Any doubts if you have, you please send Satrish. Any doubts if you have, please send also. Today doubts I will take and then we will see tomorrow. Optical instruments are there that we can take up also. Time is there means we can take. You have seen the neat result, na? Nobody expected that this will happen. Means uh, uh, the toppers who are supposed to score very good marks above 700, they could not score it because the paper got tough. But the student who was working consistently, right, she got very good results. Because in the first exam, first test, the toppers they got more than 710. But when paper became tough, they could not score marks. But the girl who scored, consistent result, previously first exam she also could not cross 700, around the same marks she got. But now she also got same mark because of consistency. Now she has become topper. That's the power of consistency. Okay. Now, let us take this question. A ray of light enters through a right angle prism. Okay, this is a right angle prism. This angle is 90 degree. Okay, the angle of incidence is 30 degree. Here, this is the normal. This angle of incidence is 30 degree. And travels through the prism parallel to the base. This ray is traveling parallel to the base. Okay, then emerges along the face. Okay, it is coming like this way, grazing the path. It is okay. Then refractive index, we have to calculate mu for this. Okay, this mu calculation is very important. Okay, let us try that. So refractive index. This is 90 degree. Okay, here if I draw normal, this is R1, this is R2. It is parallel to the base, right? Is it a isosceles triangle? Prism, right triangle they have given. They have not said what are the angles of this, right? They didn't mention that. Right. Uh, it looks like is it the minimum deviation because in minimum deviation condition only this become parallel. Okay, in minimum deviation condition only this become parallel. So, of course, here one thing is there that this E is equal to 90 degree. Okay, so deviation. Let us calculate deviation here. Deviation is I plus U minus I. Ah, hmm, hmm. Means half it will come directly. We can take half also here. 45 degree. Then we can use this here also. We can use it. Because it's a minimum deviation condition, so we can take half. So here sin 30 half is mu into sin 45 1 by root 2. Correct? So from here mu will come as correct, right? Now half here it's 1 into sin of I half is mu into sin of 45 degrees 1 by root 2. Hmm. 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 No, no. What I am saying is that if it is minimum deviation, then tell me this angle will be half of this or not? R value is half of this or not? Correct, na? Half of this. That means this is also 45. This is also 45. Correct, right? And if of course this is a critical angle here because it is grazing it. There is one idea by using critical because critical angle we are getting as 45 degree. Tell me, this critical angle is 45 or not? Tell me. Ah. So if critical angle is 45 degree, then mu will become 1 by sine of critical angle. Then 1 by sine of 45 degree. Then why not this root 2? Why not the answer is root 2? Tell me. Hmm. No, no, given means no. Tell me here. What is the wrong here? And also, I was that formula and all these things that comes from this results only. Na? Huh? So now, if you tell me from here, if I use here again. Now tell me if I use from here 1 into sine of 30 degree is equal to mu into sine of 45 degree. Law of reflection. So root, this is 1 by 2 mu into sin 45 1 by root 2. So from here mu is coming as root 2 by 2. No, no, 1 by root 2 it is coming. See, mu value is coming as 1 by root 2. Different answer in this question has a glitch. This question has a glitch. You may be thinking that I use that formula, right? Mu value is equal to sine of this delta minimum plus a by 2 divided by sine of a by 2. Correct. So here you are using minimum deviation. Minimum deviation you have got it. How much minimum deviation you got it? Minimum deviation is how much? What did you get minimum deviation? Minimum deviation is 2i plus, sorry, 2i minus a, correct now? 2i minus a. This. So 2 times I is 30 degree minus a, correct? So 60 minus a is 90 degree. So first of all tell me this is coming negative now, correct? Negative is coming, right? And then let us say even if you use this, let us use this minimum deviation. So suppose you got this as minus 30 plus 90. So 60 by 2 you will get 30 degree and here you will get 45 degree. So sine 30 is 1 by 2. This is 1 by root 2. Tell me. 60 by 2 also you have to do now. 2 you have to divide. Yeah. So 1 by 2 by this, it will become root 2 by 2, 1 by root 2. The same result which we are getting here. But that is not possible because effective index is greater than 1. So the question has glitch. This question has, how are you saying that you are getting that first option? This one? Huh? Root 5 by 2. No, no, no. This looks like some glitch is there in the question. Some glitch looks like that. Hmm. Might be something else will be there, some conditions. Isn't it? But if you take it like this, you have to take critical angle this one. This critical angle when you take, then you will be getting that. 55 means you will be root 2. I think in the question they have not made things clear. Hmm? Check whether this question is correct. Let us use another approach. Okay, let me use another approach without using this R1 plus R2 is equal to. Okay, let us try a different approach. That I will try. I will tell you that approach may work because some glitch is there definitely in this question. Some problem is there with this question. But let us not use the formula and try to use the basic concept. Okay? That I will try. Approach. Okay, so what approach I am going to try is I will not write this as critical angle. Means I will now definitely I am going to write, I will not write any value here, but we can clearly see that here this must be critical angle, right? This must be critical angle. This must be R1, we do not know. Let us not use the formula R1 plus R2 here. Why? Because sometimes this formula doesn't work. Okay? So let us say this is critical angle, and sine of critical angle we know it is 1 by mu. That we know. Okay. Now, uh, suppose if I take this R1. So according to this formula, if I use 1 into sine of 30 degree is equal to mu into sine of R1, then this is 1 by 2 is mu into sine R1. So sine R1 I will get as 1 by 2 mu, right? Sine R1 I will get. And this theta c is nothing but sine R2, right? This is sine R2. Sine R2 we are getting as mu. Now see, I will try to use this. I will try to use this idea that R1 plus R2 is equal to 90 degree, which is A. Okay, I will use this idea. R1 plus R2 is equal to 90 degree. Okay, so I will write here as I will write R1 as 90 minus R2. So I will now write as sine of R1. I will write as sine of 90 minus R2. Sine 90 minus theta will become cos R2. Right. So sine R1 is becoming as cos R2. Sine R1 is becoming as cos R2. So what is sine R1? Sine R1 is 1 by 2 mu, right? So 1 by 2 mu is equal to cos R2. So cos R2 I am getting as 1 by 2 mu, and sine R2 I am getting as 1 by mu. Let us now use trigonometry. Just we are seeing trigonometry, right? Sine square theta plus cos. So sine square R2 plus cos square R2 is equal to 1. This can never be wrong. So sine square R2, sine R2 we have got 1 by mu. So 1 by mu square plus cos square is 1 by 2 mu whole square, right? Is equal to 1. So 1 by mu square plus 1 by 4 mu square, 1 by 4 mu square is equal to 1. So from here, what do we get? 4 mu square is equal to 4 plus 1, 5. So mu square becomes 5 by 4. So mu comes as root 5 by 2. Correct? Is this option there? That option is there. Option D is there. What is the correct key they have given? Ah, yes. See, this one is clear, na? This is also clear, right? Okay. Now R1 plus R2 is A, R1 plus R2 is 90, R1 become 90 minus R2. So when I apply sine R1, that sine 90 minus R2 become cos R2, and sine R1 is 1 by 2 mu. Sine R1 is 1 by 2 mu. So cos R2 is 1 by 2 mu. So once you got cos R2 and sine R2, sine square R2 plus cos square R2 is 1. So sine square R2, that is 1 by mu square plus 1 by 2 mu square. Square you solve, then you'll get root 5 by 2. Correct? But now the problem is that why the theory is not working here. This this is not working because this should be half of this. This should be half of this. This is the minimum deviation condition. Why this is not working? Some glitch is there, I think. Looks like that. Okay, because if you use, suppose for example, this is definitely critical angle, right? And this is 90 minus critical. And from here we can clearly calculate also. Because if you take this is half of this, then you can calculate, isn't it? That means is this not the minimum? Is this not the minimum deviation condition? Because if you take minimum deviation condition, then only it looks like glitch. Because for minimum it is half of. But if you don't take minimum deviation condition, then this is how you have to do that. But we know in minimum deviation condition only it become parallel, right? No? Minimum deviation condition become parallel. So is this not the minimum deviation condition? This is a question. Try to explore this. Is this is this not the minimum deviation condition? Minimum deviation condition. It looks like not, because whenever we say minimum deviation condition, we say that base this way and this become parallel. So by just looking at this word, people will try like that way only. Okay? But when people try with like that way, they are not getting the answer. That's why brain you have to work. Then you have to then neglect or ignore that minimum deviation condition, then solve. Right? Okay. Then anything else? Any other doubts you have? Okay. So let us cover some topic today. Let us start uh, this optical instruments. Optical instruments. Optical instrument. So what is optical instrument? Any instrument which is used to visualize things, objects. And in optical instrument, we have the concept of human eye. You may say human eye is not there in this syllabus, but all of us got human eye. All of us have eye. We need to study a little bit about that. Okay. Then we have microscope. Microscope. In microscope, there are two type of microscope: simple and compound and simple microscope. And third is telescope. In telescope we have only astronomical telescope. Okay, so let us try to get some ideas about that. So what is human eye, how does human eye function, and all that is a topic of biology, but here we can think about little basic idea, okay, like this. So human eye is like a almost as a spherical, you know, like this. So maybe in bio you will be studying that, right? And there is a ciliary lens, means lens, crystalline lens is there, and that crystalline lens is held by ciliary muscles, and of course there are also ligaments, three sensory ligaments, and then there is uh, this what we call iris. Iris is like a shutter here. There is a iris, which is shutter, and in between iris there is one small like this hole. It's like the opening where light comes. Okay, that is the pupil, and then here this part is called retina. Okay, this means this entire segment, entire inner portion is called retina. So here you need to note that this lens is a crystalline lens. It is made up of some, let me put it like this. So this lens is made up of some crystalline structure. Crystalline structure. And here some medium is filled here in between this. These mediums is called aqueous humor. Aqueous humor. And this medium, these are some fluid medium, some fluid is there. Our eye have been designed, looks like our eye is not just made by chance. Right, it looks like designed, no? vitreous humor. If anything is not present, we cannot see that, right? It is perfectly designed to work. Okay, so here rays of light will be coming, and this portion is called cornea. Cornea. Okay, and this portion is called um, iris. This part is called iris, right? This opening is called pupil. Pupil. Okay, like this. This part is of course called retina. Retina. And this part is called ciliary muscle. Ciliary muscle. And this part is called presensory ligaments. Ligaments. Okay. So all these parts are important for the eye. So this cornea or this whole eye is like a sphere of almost diameter as 2.5 inch. 2.5 inch. Not sorry, 1 inch, almost 1 inch. 1 inch diameter. Okay, 1 inch diameter. 1 inch means nearly 2.5 centimeter. And how it works? This pupil is a small opening through which light will enter. So light will first hit the cornea, and cornea starts refracting the rays. And as the light enters, it will go through this aqueous humor, which is like a liquid medium, and vitreous mirror. So this aqueous and vitreous mirror, their refractive index is almost nearly 1.39 something. Okay, nearly 1.39 aqueous and vitreous mirror. 1.394 or something. But this lens refractive index of this is crystalline lens. This crystalline lens refractive index is nearly 1.396, little bit higher than that. Okay, little bit higher refractive index than that. So as the light is going to enter into that, light will start reflecting from the cornea, and then this pupil is the black color shape of our eye, the opening, which is pupil. Why it is black? Because whatever light enters into pupil doesn't come reflection, no chance of light coming from that. All light enters, so it looks like black because it's completely absorbing the light. And once light goes in the lens, then reflection happen. Then reflected light will hit and image is forming at the retina. So that's the whole idea behind human eye. It's a very beautiful structure, right? So lot of things are there that no. And some problems happen because our muscles does not work because we are too much using these muscles, right? So suppose you are seeing the nearby object, then muscle has to compress means and this structure of the eye lens can change. So this lens is a very fine structure. It can be sometimes large lens like this, and it can become thick also. When it becomes thin, when you are seeing very large distance, right, large distances you can see, then lenses change its focal length. And similarly, when you are seeing the nearby object, our lens become thick, then the focal length decreases. So the ciliary muscles plays an important role in changing the focal length. Right, so ciliary muscles always have that role, but the thing is that if you are looking at nearby object continuously, then our eye will become like this. And if you are seeing very far away object, our eye will become like this. So we have to continuously keep on changing our eyes. Otherwise, our eyes will lose that flexibility. Right? That's why doctors say, nah, that don't look continuously like at one place. You need to keep on changing. Okay, so focal length can change, but as people grow old, that flexibility changes and they have problems of eyes. Okay. Actually, there is a very advanced question can be formed on this. What? Assume that ice like this structure, ray is coming, ray will have first refraction from this spherical surface, then it is going in this medium, then it will have reflection through lens, then again it will come and hit here, then image will be formed, all that. Okay. So I have discussed in a class of advanced model on this eye, although I they say it is not there, but In some questions, JEE or JEE Advanced, they can give a question of human eye, and they will give the values of refractive index and all that, and they will say that some calculations they may ask this. Okay, so these are the things here. This is human eye. But now, what is very important to note about human eye is that now let us consider that human eye is like a spherical, like shape. Okay, and any object when you want to see, let us say that this is the object of height h naught. You want to see that. So when you want to see, assume that it is image is forming like this way, and this is the size of the image on the retina. This is the size of image on retina. Okay, this is the size of image. Size of image. Image on retina. Because retina is like this screen, on this so many nervous neurons will be there, cones and rods, these are called cones and rods. So the more the size, this is like a curved side, the more the size it will be, the more the bigger picture we can see of that. Okay, so this is angle, let us say theta o, let us say, and some distance will be there, object distance from here. uh, and this, of course, this image distance, let us keep it fixed, okay, because distance between this, we representing this as length side structure. Okay, this angle is theta now. So this distance is fixed, but this distance can change. Also note that this is the center point of this will become 2 theta naught. So this 2 theta naught is, let us say this length is L, and let us say this is radius. So L by R. So definitely this angle depends on this theta naught is proportional to this length. L is the length of the image. So larger this angle, larger the image on our eye, retina, and we get a better clarity of that. So that is the main role of the optical instrument. The optical instrument helps us to increase this angle theta naught. Okay, the main purpose of using optical instrument is to increase this angle theta naught, so that the length of this image increases on our retina and we get a better picture. Now I will give example how this simple microscope is working on that. Okay, so first of all, let us take this object. Let us say that this is the object, this is the object, and let me represent eye with like this, like dot. Okay, with some eyebrow also. Okay, so this is the eye, and now let us say that this ray of light is coming into our eye. So this object is subtending this angle theta naught. Now, this is the theta naught which we are getting. If you want higher angle, higher angle means you need to bring the object closer. But how much closer we can bring, that is the limit of our eye, right? So we can bring up to a distance of how much? 25 centimeter. This is called least distance. Least distance. For distinct vision. For distinct vision. So we cannot bring more closer than this. Why? Because then our ciliary muscle will not work. Okay. So this is, and why should we keep here? So that larger angle will be there. You can keep away also, but then this distance will decrease, angle will decrease, image on retina will not be that much clear. Okay, that is why optical instruments will. Now here we will define this theta naught or tan, because these angles are very small. So theta naught will be defined as h naught by d. This definition is not going to change. That we know that. This is definition of theta naught will not change. Okay. Now I want to still increase that. So now comes the concept of lens. Okay. Now let us understand magnifying glass or simple microscope. When we are going to use simple microscope, we have to keep a lens somewhere here. Let us keep a lens somewhere in between eye and the object. Okay. So this is our eye, and here is the object, height of object h naught, and some length here you keep here this, and this. Note that you want to focus on this image. So of course now this lens will be making an image of this object. Okay, that image can become at infinity. Suppose if I keep this distance as focal length of this, so you know that how ray will be going, right? This ray will go like this and it will go, it will pass like this, and here we take another ray. These rays will be going at infinity, that we know, because image will form at infinity. And this side dot dot, if we extend, it will look like the image is coming from infinity. So I will be focusing infinity now, because this rays, you know, will be forming at infinity, going to infinity. Okay, right? So now see here, what is this angle now? What is this angle? This angle I am taking now as theta I, because this angle is coming from the image which is very large somewhere, very large it is. Okay, somewhere it is. So this theta I will now define as theta I will define as h naught by f. Note here this f, if this f is going to be smaller than d, definitely we can make it have focal length smaller than d, then this theta I is going to be larger than theta naught, because theta naught was the formula. Theta naught formula was what? H naught by d. Correct? So if we choose a additional focal length having focal length smaller than d, then this ratio will be increasing now. So theta I will increase. So that is called magnifying power. Magnifying power. That magnifying power m is defined as theta I by theta O. Now this will be coming as how much? Take this ratio, h naught by f divided by h naught by d. So that comes as d by f. This magnifying power, this condition is called relaxed eye. This is called relaxed eye, because our eye is now relaxed, because we are focusing at infinity. Okay, and this is also called image form at infinity. Image at infinity. Image at infinity, all relaxed eye. So in relaxed eye, we found this is a simple microscope. Okay, this is now the topic of simple microscope. Simple microscope. So in this simple microscope, if you use, you can increase this angle, and now the image will get a better clarity, and this d by f ratio is going to be greater than 1. Definitely it will be greater than 1. This is the magnification formula. Okay. Now suppose still I want to increase magnification. What I will do is, I will do something more here. What? I will try to bring this see, note that this eye is almost close to this place. Okay, eye is almost close to this lens, so there is no worry about where is the eye. Eye is near this lens itself. Okay, now suppose I want the final image not at infinity but final image at least distance. Let us try that condition. I want final image at least distance. So this is the lens. I is very close. This is the object h naught, right? This is the object h naught, and I have to definitely keep within the focus now. This distance of the object is within the focus, because this is the focal length now. Okay, so you know what happens in this case. The ray goes like this and it passes through the focus that side, and if you take another ray which will be passing through this ray are actually going to be diverging. You know that, right? This will become diverging. I will call it here. Okay. This ray is going like this and this ray is going like this. So these two rays becomes diverging, right? These two rays become diverging. So as these two rays become diverging, our eye, what our eye will see? This is our eye. Our eye is collecting these two rays. Okay. So what our eye will see? Our eye will see that it is meeting somewhere here, right? So this is what the image we will see now. Remember this, now theta I is this one only. This is theta I, Now tell me what is theta I. So theta I now becomes h naught by u naught. Note that this u naught is object distance is less than focal length. So definitely this angle, this is greater than previous. So now magnifying power you calculate. Magnifying power is equal to theta I by theta naught. Theta I is h naught by u naught, and that is h naught by d. So we get d by u naught. This is the case of stressed eye. Stressed eye it is. Stressed eye. Okay. And note that the final image, we are putting the final image where we are putting, where we, this final image we are getting at least distance. This is the idea. Stress eye means image is at, image is at d equal to 25 centimeters. Okay, image is found at 25 centimeters. So now let us try to calculate what will be that. So now let us use the formula 1 by v minus 1 by u is 1 by. Okay, let us use that. So of this distance we know image is forming that side only. So v is minus d here, minus 1 by u. Suppose if I take u as u naught, this distance I am taking. So I will write us minus u naught here. Focal length is 1 by f. So from here I get as what I get 1 by u naught, I get as 1 by d plus 1 by f. So this let us substitute it here. Then formula for magnification will come from here. So magnification formula now that we get after substitution is d into 1 by u. This is 1 by d plus 1 by f. Open this bracket. So magnification formula becomes 1 plus d by f. This formula for magnification, remember simple microscope for this stressed eye. So that's what it is, right? That's the important result. So let us keep it up to here. Then we'll see tomorrow. We will further continue and we'll finish this topic. Very small topic it is, right? Then we can work out questions. And NCRT has good questions on this. Okay, at least the old NCRT or previous NCRT. Fine. Yes. So let us meet tomorrow. Next class. Bye. Good night. Yes. The praise and thank you. Good night. Bye.